Hello, welcome to the Python crash course. During this crash course, we will be showing you the basics of how to use Python. Wait, one moment. Um, so for this course, we will require that you have Python 3.9 or later if you wish to follow along. Oh, by the way, you can unmute now if you have any questions. So, do all of you have Python installed? If you want to follow along. Okay. Okay. Um, so to install Python, you need to go to python.org. And now on Windows, this is how you do it on Windows. If you're on Ubuntu, if you're on Linux, you're probably going to have to install it from a package manager. Ubuntu Home probably has an installer. macOS also has an installer. So you just need to download the installer and launch it and install Python. But for this course, we will assume that you have Python 3.9 or greater, and you can check that by running Python-V. So, let's get started here. Hello World, the classic. How are you up to this point? Um, hello? Having everyone muted is kind of unnerving me. So, also, for this, okay, for this course, we will recommend that you have at least a little bit of experience with software development. Well, not experience with software development, but experience with computers. Like, you know how to open a command prompt and a terminal window and that kind of stuff. So this is a function or a variable, and you'll put these parentheses after it to indicate that it is a function, that you're calling this function. So I just called print, and then inside these parentheses, I put two single quotes with the text that I want to print. So hello world. Now, unlike other languages, Python does not require a semicolon at the end of a line. So let's run our first Python program here. As you can see, it outputted hello world. Okay, can you ask that again? Yes, good question. S- Um, we'll get into that later. So, so print, so there's these things in Python called objects, normally known as also known as variables. So they can be either a string or a number or another kind of number or even complex numbers. But we won't get into that in this course. So the difference between strings and between words and numbers. So like you might think that these are the same, but no they're not. This is a string. It is made up of individual characters, and so it's text, whereas this is a number. It's stored in numbery ways in the computer. Um, they are mutually exclusive. So if I say var1 plus var1 and run it, you can see it says 5, 5. Not 55. 5, literally 5 again. Whereas if we say var2 plus var2, we will get 10, because 5 plus 5 is 10. And you can't add these together because strings and numbers are incompatible. You can make them compatible by converting them to a string or a number. This is another function called str that will take any value, including numbers, and return it as a string. So a bunch of letters. As you can see, that takes this string and it adds the string representation of this number to it, giving us 5, 7. Now there's another function called int that does the exact opposite. It converts a string to a whole number, an integer, giving us 12, because 5 plus 7 equals 12. Yes? Yes. It keeps it as a number. That is one of the beauties of Python. Okay, so that's all well and good, but how do we create our own functions? Ah, um, we'll get into that, um, because you wouldn't necessarily want to know about other ones before you get into making your own. No, it's okay. So to create your own, you say def and the name of the function, followed by those same double parentheses. But inside of these parentheses, instead of passing the value or variable that you want, you pass the name of a variable you want to get when the person passes that. So if we say func5 here and print jumbo, we will see that jumbo is 5. Because we passed 5, which assigned to the value jumbo, and then we printed jumbo. Inside these functions, they're useful because you can do other things, like the classic square function will square a number. However, in Python, there's a better way to square numbers than multiplying a number by itself, and that's to just use the exponent operator, which works with any exponent. Also never mind. Something interesting about Python is that instead of is a division symbol doesn't divide. If you divide a whole number or an integer by an integer, it doesn't give you an integer back necessarily. It will give you the actual result of your operation, which in this case is 1.6667. However, if we use 2 slashes, it will divide and then floor. Actually, it will truncate, but if you're a math person, then you know the difference between those, giving us 1. Now, classic thing about programming, the if statement. You've probably heard of it. Yes? Yes? Yes. Yes. Right here. Yes. Yes. Yes, it will. It will, actually. So if we say 5.5, it will also, well, actually, it will, the thing with doing that, though, is it will truncate, but it will still keep it as a floating point number, which means that you can't do bit operations on it. But I'm not sure we'll cover bit operations in this course. It's a little bit advanced. So now the classic programming if statement. It's if followed by something like this. This will return a value, the value times 2 if it's less than 5. Otherwise, it will divide it by 3. So that was not less than 5. Neither was that, but if it is less than 5, what it will do is it will multiply it by 2 instead of dividing it by 3. Yes? No, Python does not use curly braces. It uses colons and indentation. The amount of indentation defines how deep you are in a block. That helps avoid unreadable code like this. This isn't actual code, but you can't tell how deep you are in the program because there's no indentation. Yes, that is valid Python code, actually. So that is, we'll get into that's some more advanced stuff in there, and that actually brings up something that I forgot to talk to you about. The input is the exact opposite of print. If you give it a string, if you don't give it anything, um, then it will, if you don't give it anything, then it'll just wait for you to type a number. It'll just wait for you to type a value. However, if you pass it a string, it will display that string and then wait for you to type a value. Next, the while loop. No, input does not include the new line. It is completely ignored. The while loop is like the if statement. However, the difference is instead of just checking once, it will check it once, and then it will do what's inside of it. It did. I didn't have the space there before. So the while loop, instead of just checking the statement once, it checks it once, does what's inside of it, and then it checks it again. And if it's false, then it's done. If it's still true, then it does it over again. Also, besides the int function, which works only with whole numbers, there's also the float function, which works with any number, whole or not. This function will multiply it by 2 until it's not less than 5, and then it will divide it by 3. Wait, one moment. Okay, I'm back. So this function multiplies it by 2 until it's no longer less than 5, and then it divides it by 3. However, something you need to be careful with when programming is things that will never end. Negative 5.5, this will never end because multiplying it by 2 will give us 11. Will give us negative 11, which is still less than 5. Multiplying it by 2 again will give us negative 22, which is still less than 5. And it will keep multiplying it by 2, even though it's always less than 5. And this brings up an important point in Python, because Python, unlike other languages, will never overflow. It will never reach a point where the number is so big that the program will stop working. A very special thing about Python is that numbers can get infinitely large. However, this only applies to integers. It does not apply to floats. Floats still have a breaking point. The breaking point is about 10 to the power of 308. So you're safe there. And then multiplying it by 2 will still not stop the program. It will just result in the float having a value of infinity, which is some advanced computer science stuff. Now, something a little bit more complicated. The for loop. Crunchy Crisp, that applies to single precision floating point numbers. Python uses double precision floating point numbers. There's one other kind of loop that does things multiple times, and that is the for loop. The for loop is something along the lines of this. It's for a variable in a sequence. Range is a sequence of 5. Is a function that will return the values 0, 1, 2, 3, and 4. Which we can see yes, pass is something built into Python, and it means literally do nothing. Now, this is because of the indentation thing. If there's an empty line here, then it just sees no indented stuff, no indented space, and it gets confused. So pass is a no-op. It does literally nothing, but it allows you to have empty statements like this. It gets confused when there's a colon and it expects an indentation, but there's no actual indentation. What do you mean? Um, it doesn't get confused. It just doesn't. This is invalid syntax. This is not correct code. It won't run. It expected an indented block, but it didn't get one because this is the same indentation. So pass just does nothing. There's an alternative to pass, which generally implies that you'll fill it, that you don't plan to fill it out ever. And that's 3 dots. But that implies that you won't fill it out. Yes, correct. Oh, no, it's fine. So, range is just one such thing. We've already covered numbers and strings of characters. However, what we also need to cover is lists. These are objects just like any other. However, what's special about lists is that they can contain multiple values. Like such. You can also add values to an array with this special dot operator. If you use a variable name and then followed by a dot, it means to do something with it. So if we do var dot append, that will call the append function of var. Now, if you are a computer science person, I know it's supposed to be a method, but I'm being simple here. So it will call the append function of var to add a value to the end of the list, like such. there are something that Python supports that some other languages, yes, that is a feature of Python that isn't supported by statically typed languages. Um, Python supports something that a few other languages don't support, like Java. It supports something called operator overloading. Earlier when I said 5 plus 5, remember that, right? I did 5 plus 5, and it gave me 10. So something special about Python is it lets you, if you create your own type of object called a class, it lets you override, lets you change what the plus operator does. So doing 5 plus 5 is the same thing as doing var dot add another 5 to it. You shouldn't do this. You shouldn't call the function like this. This was just for demonstration purposes. Which brings us to another big feature of Python. Classes. Python is an object-oriented programming language. Is an operator-oriented programming language. Meaning you can create, so you know how these are numbers, also known as ints. These are strings, also known as strs, and these are floats. Remember when I was calling them, I was saying int was a function, str was a function, and float was a function. These are not actually functions, these are classes, and we're creating new instances of these classes. We're creating new objects from these classes by calling the class like a function. Oops. Which means that we can derive from them, but that's later. So let's get into creating our own custom classes. We can do that using the class operator like a function. However, it's class instead of def. So we'll just call this class hello and give it an empty body. Now we can create a new instance of this class and print it just like other objects. As you can see, it's a hello object. Now the reason it doesn't, yes, you are supposed to create class names with a capital first letter. It's just the convention, but it's the convention you should follow. It's one of the most important conventions. One of the most, necessary conventions. Yeah. So, this looks so, weird because we have not told the print statement how to display a hello object. We can do this by those double underscores again, creating a double underscore str double underscore function. This is supposed to return what the print statement should display and what the str statement and what the str constructor should return. I'm just going to call it a function for now until we get into constructors later. As you can see, it prints hello because the string representation of a hello object is the word hello. Now, how do we store data in this hello class? Well, that's simple. We create a double underscore init double underscore function. The thing in Python is double underscores indicate a special function. So we can accept arguments to this just like normal. However, first let me point out this self argument. This is the first argument of a function, and just like this in other languages, it references the current instance of the class. Now, this is an argument to the function, unlike in other languages where this is just kind of something that just exists. We can accept other arguments to functions and methods by adding a comma after this, and then typing in the name of our second argument. We can assign a value to ourself by saying self dot, that dot operator again, and just coming up with a variable and assigning it the value. So, yeah. Shh. Um, sure, fine, I'll do that, Crunchy. So now we can add a space here and add a plus with self.banana. And if we run this, we'll see that it won't run because we didn't pass the banana argument to this function. And so we'll pass the banana argument as apple. I still want to go against the laws of nature here, by the way. If we run this, we'll see that it says hello apple because we passed apple here and then we print it later. So as you can see, classes are a very good way to store data, store multiple pieces of data. However, classes are much more than that. They also allow you to manipulate their data with the use of methods. So far, I've only used methods with double underscores. By the way, a method is a function that is a part of a class. So if we just create a method called meth here, of course self has to be the first argument, and we can pass other arguments. However, we'll modify banana to multiply itself by 2, and we'll use this new times equals operator. You see, unlike equals, times equals is the same as saying, instead of saying, we can say blah equals blah times 2, but that's long. So how about we just say blah times equals 2? That's much shorter. Now this works for most operators, including plus equals, divided by equals, int divided by equals, minus equals, etc., including power equals. Yes, modulus equals is also a thing, fancy. So if we then say h.meth, and we pass no arguments here, because self is just a part of Python, it will always pass the current instance as the first argument, unless you use static methods, but I'm not sure we'll cover that here. If we will, it'll be later. As you can see, it multiplied the word apple by 2. There's now 2 apples. Hello, apple, apple. 1 second. Okay, so now you can see the questions that people are asking in the corner here. So where were we? Okay, modules. Modules are an incredibly handy tool. They allow you to store data, to store things like classes and functions, and classes in their own file. So now if we create another file, we can import the first file. Notice that you don't include the .py at the end. You just import the file without the py. And this won't work if it doesn't end in a valid Python extension, like py or pyw. So now we can access it with our friend, the dot operator. We can say print hello, print classes.utility. Hello world. Notice that this PyCache folder appeared. This compiles, Python compiled the classes module and saved it in this binary file for us, so that if we don't make changes to the classes file, it doesn't have to recompile it. It just does it once. Basically, it speeds up your program. So this is the basics of importing. However, you can alternatively do from classes import something, at which point we don't have to use the dot operator. We can just say utility directly. This has also the powerful feature of renaming values, of renaming things. So we just renamed utility to util. However, that only applies for this single file here, client.py. Other files still imported as utility. As you can see, util here exists. However, if we change it to utility, it no longer exists. It's not defined. Yes, that would be useful. However, if you have conflicting names, instead of importing and renaming, what you should do is you should just import and use the dot operator. You can also do import star, which will import everything. So as you can see here, we have both utility and hello. Now back to that operator overloading. We overloaded the str constructor and the init and the hello constructor. However, we can also override things like multiplication. Mul is for multiplication. I literally just explained that. Sorry. So if you're just gonna have to memorize things like mul here because yeah. However, mul is for multiplication. So if we we accept the classic self, argument, but we can also accept the b argument. But we also have to accept a second argument, normally called other, that is the other hello object. Or not necessarily a hello object, it's just the object we're multiplying it with. So if we return 5 here, and then we create a hello instance, and then if we print var times 2, 5, because logic, because we multiplied self by other and we returned 5. So maybe what we could do is we could create a new hello instance with self.banana times other. Now var times 2 will simply be hello banana banana. var2.banana will be banana banana. But printing it will print hello banana banana. Yeah, Batman, I know. Banana Batman. I think that's how it goes. So I'm not going to go into what the other operator overloading methods are called unless you want me to, because I've explained the basics of operator overloading, and if you want to overload other operators, you can look it up on docs.python.org, which is the Python documentation. I will have that down below in the description if you want to check that out. So we imported star and we did this. However, there's another thing to do with functions. Optional arguments. Yes, times equals. Yes, I should have talked about that. By default, if you define a mul function, it will work. However, this is slow. This will work because what it does is Python will expand this into this for us. However, we can overload this directly by using, instead of mul, if we use imul for in-place multiplication, then it's actually supposed to do the same thing as mul. It's supposed to return an instance, and it will be assigned back. However, the thing with imul is, since you know that it will be assigned back, instead of doing this, you can just multiply self.banana times 2 and then return self. This will cut the overhead of creating, this will cut down on the overhead of creating a new hello object, because all we do is multiply banana times equals other, and then return our self, which is ourself. And yeah. So as you can see, this will have the same result. This brings up something about Python. Unlike other languages like C, Python has no notion of passing values. When you give something to a function, you don't give it the value. You give it a reference. You give it itself. If we print var, we don't print the value of var. We don't pass the value of var to print. We pass var itself to print. We don't clone var and pass it to print. We pass itself to print. We can verify this by using the built-in id function. The id function will print the ID, or special identification number, of a variable. So the ID of var, and we create a function, and we print the ID of var1, this will have the same result. They are the same object. Yes, JavaScript does do that. Some languages don't, though. Like C. C, you have to actually pass a pointer with weird stuff like this stuff. You can. You can. I don't. However, I know that passing, you can pass by reference, which is what Python always does, or you can pass by value, which just passes the value. Python passes primitive type by reference. It passes everything by reference. However, the thing with numbers is they're immutable. So if we say, if we say, if we pass, if we say the ID of 1, if we say var equals 1, and we print the ID of var, and then we multiply var times equals some number, and we print the ID of var now, it will be different because the numbers, even though we pass a reference to the number, it's still the same number. But if we change the number, we don't change the original number, we create a copy of that number and perform the multiplication. But it gets copied when we perform the multiplication, not when we pass it to a function. This is the reason why Python has no plus plus or minus minus in the language. It's kind of hard to explain which objects are mutable and which ones are immutable. Immutable ones are generally ones that are written in C, because you can create classes, but you can create Python classes in C, at which point you can decide if they're mutable or immutable. Python objects will always be mutable. Actually, that's not true, because there is no really mutable or immutable. That's just a term. There's no real mutable or immutable. What it is that because they're all mutable, we can change the value of a string or a number with weird stuff, but you're not supposed to. It's more about what you should do or shouldn't do. There's no real boundary between mutable and immutable. They're all references. Generally, if it's something that doesn't have a way directly through Python to change it, you shouldn't change it. However, default arguments are something in Python. We can say var equals 5 here. My function var equals 5. If we call my function with 10, it will, wrong Python file, it will print 10. However, if we don't call it with anything, it will print 5, because that's the default for the argument. Unlike some interesting languages like Visual Basic, you can't have non-optional arguments after an optional argument. Unless you do keyword operators, but that's advanced. So let's go into keyword operators. I said it's more advanced, but we've kind of covered the basics here. So keyword operators are like this. Var blah. Here's the thing though. We can pass blah before var by saying blah equals 5 when we call the function. Yes, I know JavaScript can do that. We just pass those out of order. Let's do something that can't be. We just pass those out of order. We pass them in a different order than they were originally specified. You can prevent people from doing this, however, by including an argument that's just a slash. This means that var cannot be passed like this. Var has to be positional. However, we can pass the arguments after the slash out of order still. Keyword arguments are useful for functions that just have a ton of different options, and you're not generally going to pass all of them. You can also include a star, which means that these is the opposite of a slash. So everything before a slash can't be passed by keyword. Everything after a star must be passed by keyword. So we can't pass like this, because it only takes one positional argument. The rest are keyword only arguments. What do you mean by combined? Everything before slash can't be passed by keyword. Everything after an asterisk must be passed by keyword. It can't be passed otherwise. So now that you have learned the basics of Python, I'm not sure if I should finish here or show some of the power of the standard library. I mean, there's like hundreds of standard library modules. How about I show some of the more power of built-in objects like numbers or strings? I'm going to do that. Okay. So numbers have built-in feature. Yes?
Can you verify I updated my question? Can you verify that it's typed correctly now?
Yes, everything before slash can't be passed by keyword. Everything after an asterisk must be passed by a keyword. Correct. There's just a bunch of features here, like as integer ratio is, will for an integer will always return itself over 1. Will always return itself comma 1. However, for a floating point number, it will return a fraction, numerator comma denominator. Also, you might notice these. This is the same thing as a list. However, unlike a list, it's not a list, it's a tuple. Tuples are different from lists because they lack things like append, or or insert because they are immutable. They are immutable lists. Um, Also, that forgets something. That reminds me of something that I forgot about lists. You can change. Correct. You can change the value. You can change values in an array. And Python uses zero-based in a list. Python uses zero-based indexing, meaning the first item is 0, the second item is 1, the third item is 2, and so on. So if we change the last item, if we change the middle item here, the first item, item 0, we can change it. And if we then print L here, we'll see that it is HL to 1, because we changed the 5 into an HL. And a cool feature, yes, you definitely have yeah. Um, um, you can change the value. You can go backwards as well. Going backwards uses 1-based indexing. -1 will reference the last item. -2 will reference the second to last item. -3 the third to last item, and so on. So now we'll change the last item to HL. Now we need to cover another built-in function, len. Len will return the length of something. For lists and tuples, it will return the number of items in it. For a string, it will return the number of characters. So if we print len L, we will discover that it is 1, 2, 3, 4, 5, that it is 6. So assigning to -1 is the same thing as saying len L minus 1. -2 is the same thing as len L minus 2. Python is just smart and abbreviates that for us. One thing that I forgot to cover, dictionaries. Dictionaries are like lists. However, instead of using zero-based indexing and all that, they use keys. So like the value in the dictionary of hello is world, and the value apple is banana. And oops. As you can see, hello is world and apple is banana. You can also specify this here, like this. However, you use colons. Yes, you can. That is one of the features of the Python standard library. If you import pprint, notice that you don't have to have an import statement at the top, although you should have your import statements at the top. Pprint contains its own print function, known as pprint. pp is also short for pprint. So if we pprint L and we pprint D, we'll see that it actually prints the same thing because there's not enough values in this dictionary to make it do it in multiple lines. One second. So you can also define a dictionary like this. Notice the use of colons instead of equals signs. This is very similar to JSON or JavaScript object notation. And if you're coming from JavaScript, you will recognize this quite a bit. It looks very similar, except I'm using single quotes instead of double quotes. Trailing commas are allowed. That is a feature of Python. However, if you prefer equals signs, you can use the dictionary constructor and a bunch of keyword arguments, which is dict. Notice, however, that I am not adding quotes around these because they are keyword arguments, like we covered earlier. This partially diminishes some of the power of dictionaries because dictionaries can have any immutable object, not immutable object, but they can have any hashable object, which is basically anything you can pass to the hash function, which is all the built-in immutable objects and none of the built-in mutable objects, and also custom classes unless they define an equals function. And if they define an equals function, they have to define their own. And I'm not going into that right now. But you can use any immutable object as an argument. So that means integers, floats, tuples, but not lists. You cannot use the list. You cannot use a list as a value, as a key, because it's not hashable. Because all the built-in types that are mutable are not hashable. However, we can use tuples. So if we call the tuple method, the tuple constructor, to turn the list into a constructor, we can use the tuple as a key.
I'm guessing you can use a list as a value, just not a key, right?
Correct. Yes. Also, something similar to dictionary. Yes, that is a thing. You cannot have a dictionary as a key, though, because it's mutable. But you can have it as a value. Also, sets. Can be defined by just calling the set constructor directly, or like a dictionary. Sets are very similar to mathematical sets, where they can only contain one of the same value, which is useful for keeping track of things in programs because they're very fast. However, like dictionary keys, they must be hashable. So we can add 15 to this, but if we tried to add 10, notice that there's no duplicate values. Whereas with a list, we can have wait, oh, we can have duplicate values in a list and a tuple, but you can't in a set, which is very useful for, like I said, keeping track of places you've been, for example, because you can only add it once. Checking if a value is in a set using the in keyword, because that's a thing in Python, is much faster than checking if it's in a list. Because all it has to do is Yeah. If MP will probably ask me if he watches the YouTube video. So, that concludes our that that concludes our Python crash course.